Right, so this is our final topic. So our final topic for control 2. Okay, so the final topic will be covered Lyapunov, so which is based on the previous class on last week. Okay, so after that, after you the Lyapunov covered, so finish for the control 2. So the last class will be take about half an hour maximum. So I think I will proceed with the lecture. Okay, so can you see the slide? Anyone can respond.
We can, sir.
All right. So the final title is Lyapunov. So before I proceed with the lecture, I would like to recap what we have done on last week on the final chapter for the nonlinear system. So in the previous class, uh, I gave you I gave you a nonlinear system. Okay, this is a nonlinear system. How you know this is a nonlinear system? Because of this parameter, x power of 3. This is give the system become nonlinear. And then after that, we convert this nonlinear system to the state space form x1 dot equal to x2, x2 dot equal to this one negative 1 over 4 x1 plus 1 over 4 x1 square plus 1 over 2 x2. This is what we get after we convert the nonlinear system to state space. And then after that, we calculate the equilibrium points. Finally, based on the calculation, we get the equilibrium points at this position 0, 0, 1, 0, negative 1, 0. All right. So there are three equilibrium points for this nonlinear system. So after we obtain the equilibrium points, then we can linearize the nonlinear system become linear system. So in this case, there are 3 points from based on the calculation. We just need to choose only one point. Uh, in the example or during the class, I was select I select 0, 0 to linearize the nonlinear equation. So finally, this is the linear equation based on the 0, 0 equilibrium point location. All right. And then after that, I give you some introduction regarding to the linear system. So for today, we want to check the stability of the nonlinear equation or system using an energy equation known as Lyapunov lah. So this is the final part. So previously we have this nonlinear system. Okay, we have the state space, we have the equilibrium point, we have the linearization of the nonlinear system. So now we want to check, is it the system stable or unstable? So the nonlinear system is for x squared, the same question. And then after that, we have the energy or Lyapunov equation here. So this is the energy or equation. So now we want to check this nonlinear system stability by using this energy equation. Okay. So for your information, the energy equation can become any. Okay. Some of the energy equation like this, some of the equation like that. So there are so many types. Okay, I give you an example. One of the another energy equation. Somehow the energy equation something like this: Vx equal to x1 square plus 1 over, okay, something like this. It become any. So in this example, I use this energy equation in order to determine use this energy or Lyapunov equation to check the stability in this example. Okay, so in order to proceed, we must have the non-linear equation in this state space form. After you have this thing, then you can proceed to solve this equation. So as I mentioned before, the v dot x is greater than 0, and we have two types of situation. So which one show the system stable, which one show that the system is unstable? Number one or number two? Number one shows stable or unstable? So I need to check. Okay.
Unstable.
Number one is unstable. Yeah? I cannot read the text. Sorry. So number one is unstable. How number two should be stable? Okay. All right. So now we want to test. Is it? We want to test. Is it the system applied to this energy equation, the V dot greater than 0 or the V dot less than 0? So let's see. All right. So now what you need to do, for sure, because this is V dot. So you have the Vx here. The Vx here is actually equal to x1 square plus 4 x2 minus 2 over 3 x1 power of 3. Okay, so you need to find the v dot x equal to what? Okay, since there are two parameters here, x1 and x2, so the v dot x actually equal to dv x over dt lah. So you need to find the dv x over dt lah. Alright, so you need to find the vx okay in term of x1, and then you need to find the dvx over dt in term of x2, because they are x1 and x2. So that's why you need to do the derivative of x1 and also an x2. So firstly, you have this vx here. If you do the derivative of vx according to x1, what do you get? I rewrite again the equation, x1 square plus 4x2 square minus 2 over 3 x1 power of 3. So let's say if you do the derivative this based on x1, what do you get? Just tell me, I will write the answer. Okay, so this one, if you do the derivative based on x1, what do you get for the first part? Again, we try to make it half an hour. If you give
X1.
2
X1.
x1, however you need to x1 dot.
Two.
Okay, firstly, because we do the derivative for the x1, so that's why we need to find to get the x1 dot. So you not only 2x1, however it will become 2x1, then you need to derivative of x1, then become x1 dot lah. Next, how about this? If you derivative based on the x1, what the answer will be for the second part here? Plus 0 minus with How about this one?
minus 2x1 dot
Minus 2 x1 must be power of what?
2.
2 and x1 dot. Alright. So help me to solve if you do derivative based on x2. So what the answer will be? For this part. How about this one will become if you do derivative based on x1?
0.
0 and then plus with then next will be
x2 dot
and then x2 dot and finally
0.
minus 0. Okay, so you need to combine lah. You need to combine. So finally you will get the v dot x become 2x1 x1 dot minus 2x1 square x1 dot and then plus with 8 is it x2 x2 dot. All right, so this is the v dot x equation. So now we have this thing, you know that the v dot, you know that the v dot x equal to x1 dot and then minus 2 x1 square x1 dot and then plus with 8 x2 dot. Okay, we need to confirm again. To x1 dot and then minus 2 x1 square x1 dot and okay. Right. So also we know that x1 dot equal to x2 and x2 dot equal to minus 1 over x1 plus 1 over 4 x1 square plus 1 over 2 x2. So these two things we obtain from this one. We have the nonlinear system and then you convert to the state space. This is the state space lah. So you know that x1 dot equal to x2 and x2 dot equal to negative 1 over 4 x1 plus 1 over 4 x1 square plus 1 over 2 x square x2, sorry. Okay, so now you know that in this case we have x1 dot, so you need to replace x1 dot equal to this equation and then you have x2 dot replace to this equation lah. So finally you get v dot x 2x1, the x1 dot actually equal to x2, okay, minus 2 x1 square, x1 dot here actually equal to x2, okay, plus with 8 x2, the x2 dot here actually refer to this one, minus 1 over 4 x1 plus 1 over 4 x1 square plus 1 over 2 x2. So you need to solve this equation. 2x1 x2 minus 2x1 square x2 plus v. So this one should be the multiplied with this one should be negative 2x1 x2. So this apply multiplied with this one should be plus 2 x1 square x2 and finally multiply with this one should be plus with 4 x2 square. Okay, so when you settle it up, this one can be cancelled up and then these two also can be cancelled up because one positive and one negative. Finally, you get 4x2 square v dot x. Okay, so now I want to ask your opinion. Is it v dot x greater than 0 or v dot x less than 0? Is it system stable or unstable? What do you think based on this equation? What do you think?
Unstable.
Unstable. Do you have any explanation to your answer based on this equation? What do you think? Just give some explanation only. Why this equation will become unstable?
Positive.
So maybe you can say something like this. Whatever value of x2, is it positive value of x2 or negative value of x2? So if you make it, you just square the positive value or negative value, then it will become positive, is it? So the positive value multiply with the 4, you will get always positive value of the v dot x. So that's the reason the system is unstable. Okay. So as conclusion, we can say that this is the nonlinear system. Okay. And then we can test the stability by using the Lyapunov equation, or we can say as that by using the energy equation. So the energy equation can be any, and many type of energy equation. So this is the first example of the energy equation, and this is the second example of the energy equation. However, in this example, I use this energy equation to determine the stability of this nonlinear system. Okay, so the nonlinear system must be converted to the state space equation first. Then after that, we must know the condition, which condition to will determine the system stable. The condition v dot x must be less than 0, then the system stable. And then v dot x, if greater than 0, the system will become unstable. Okay, that's the condition. So what you need to do, you have the vx equation. So now you need to find the v dot x equation here. Okay, v dot x equation. So since there are two parameters here, x1 and x2, so that's why you need to do the derivative based on x1, and also you need to do the derivative based on x2. So this is the answer for the v dot x equation. Okay, so now after you have the v dot equation, so you have the x1 dot equation equal to what, and x2 dot equation to what. So you need to replace all the information here to the v dot x equation that you obtained before. So finally, after you do calculations on, this is the final answer for the v dot x. You got the 4x2 square. So it means that whatever x2 value that you use, the result of the v dot x always positive, then the system is unstable. Okay, so that's the function of the Lyapunov. It's quite simple and easy. Right. So that's the end of the nonlinear chapter. So there are three important topics. Firstly, you have the nonlinear system. Then you need to find the equilibrium points, and after that, you need to linearize the nonlinear equation based on the equilibrium points. And finally, you need, or you can check the stability, check check the stability of the nonlinear equation using Lyapunov or energy equation. All right. Okay, I think that's all for the topic, and also that's the end of the control engineering too. Uh, Contents. I need to save this one. All right. So let's see if you don't have any question. Uh, so the class is dismissed. However, I would like to remind you that please fill up the student evaluation form that I post in the WhatsApp group. Maybe I can post it again right now. Please help me to answer the survey. Okay, I need to post it again. BSDC. Answer the survey. Okay, so let's say if you don't have any, you can leave the meeting. I will wait another 5 minutes to answer any question regarding control or FIP. All right, I think that's all. Thank you so much for your time and attention.
Thank you, sir.